All right. Well, good morning, good afternoon, good evening, wherever you are in the world when you're watching this, or if you're watching this after the fact. Thanks so much for tuning in and welcome. We're going to go ahead and get started here. We're welcoming you to the Optimizing and Securing Microservices-based Applications webinar. Today we've got Epsagon and we've got Alert Logic with AWS, of course. I'll let our speakers introduce themselves here. Jeff, Barr, Jeff.
Oh, hello, everybody. My name is Jeff Barr. I'm Chief Evangelist for AWS. I have been working at Amazon for almost 18 years.
Wow. Matt Brayley-Berger, I'm part of the business development team here with serverless at AWS. I've been here about 4 and a bit years. Very excited to be here. Jack?
I'm happy to be the second Chief Evangelist on the panel. I'm the SVP and Chief Evangelist at Alert Logic, providing MDR solutions. I've been doing security for about 30 years.
Awesome. And Ron?
I'm the CTO and co-founder at Epsagon. We love modern applications, and we're focusing on giving observability for engineers.
Fantastic. All right. Well, let's kick things over here. Jeff, I'll turn things over here to you to maybe start off with, and let you go ahead and begin.
Excellent. Thank you, Matt. And thank you, everybody, for attending. We have really enjoyed putting this webinar together for you. And we really focused on, as we like to do at Amazon, what we call customer obsession, and making sure that we're delivering the information and the perspective that is going to give you a better view into what it is that we're discussing here. So I'm going to talk just a little bit about the concept of microservices. And let's start off here with a quote from my colleague Adrian. So Adrian first came into my view when he was working as a cloud architect at Netflix. They were one of our really great scalability success stories. And one of the things that they did at Netflix was they said, let's make this implementation all about microservices and serverless, which are really part and parcel of the same technology. So what Adrian said here, he says, serverless app development isn't an incremental change. It's a complete reset in terms of the speed and cost and scalability of what can be built. So starting off, right off the bat, we're saying pretty big changes in store when one decides to go for serverless. So let's take a look at why serverless makes a great fit for a lot of corporate applications. What we see is that the typical corporate applications have a lot of very complex business logic embedded inside, often the result of years and years of improvement and iteration and refinement as you take your complex business processes and encode those into your applications. There's often a workflow component as you're moving people through a series of steps. But oftentimes these applications are relatively small as far as the amount of code, but on the other hand, they're absolutely mission critical. So when we talk to customers and they tell us about the fact that they sometimes have on the order of multiple hundreds of applications, not an unusual situation at all. On the other hand, these applications typically on a day-to-day basis, they'll have fairly low utilization. They don't need a lot of memory, they don't need a lot of processing power, sometimes they don't even need a whole lot of storage. But at the point when they do see use, sometimes they might be something you use at the start of the week, the end of the week, maybe they're month-end reporting, maybe they're part of some quarterly or annual process. Those workloads can spike by a factor of 10 or 100 or sometimes even more. So they do need to, in the more traditional fixed resources model, they need to have resources available to deal with these relatively infrequent but very spiky kinds of workloads. Because of the way applications have traditionally been built, it's typically one big ball of sometimes very, very old code. It's one monolith that can be a little bit just all entangled together. And sometimes a little bit hard to decipher, figure out exactly what's there. What are the good parts? What are the legacy parts? What are we using? What have we actually left behind but are sometimes still maintaining? Because of all these factors, it turns out that these serverless apps can actually be fairly difficult and costly to host and to run. You need reliable infrastructure because they are mission critical apps. Sometimes you don't need a whole lot of it because they're just not used all that often, but you need to say, we need that capacity in reserve for those spiky workloads. You put all these things together, you find that serverless is actually a great fit for these complex corporate applications. So what happens when our customers start taking these once monolithic applications and say, let's move to serverless. What they'll do is they're going to break up this monolith. They're going to take this code. They're going to start to carve out these individual pieces of business logic that were sometimes deeply entangled and connected to each other. And they're in the most ideal way, they're going to start constructing some reusable single purpose building blocks. They're going to take all this business logic, turn it into individual functions. They're going to connect these up by events. Now, every organization, one of the kind of interesting things that we've noticed here as companies make this move, the change in software architecture from the monolith to serverless is often accompanied by a change in organizational structure. So instead of a monolithic developer team that's responsible for entire apps, you see that the developer teams actually will start to align themselves along the boundaries of the individual microservices. Within Amazon, for example, we have a model that we call a two-pizza team. And the idea of a two-pizza team is that individual teams, and we try to keep them small enough so that they're comfortably fed by about 2 pizzas, individual teams are responsible for designing, building, running, evolving, maintaining individual microservices. The fact that these microservices are isolated and independent and they are connected only by well-defined APIs and activated by events gives each of these teams the ability to innovate on their own. With the monolithic applications, you typically find you have to have a very stair-stepped kind of everybody needs to proceed in a locked fashion. The independently built, maintained team model gives a lot of license to the individual teams to evolve at their own pace without having to do as much detailed day-to-day coordination with the other teams. Right there. Oh, little skipped ahead there. So some of the benefits that we hear from our customers, they enjoy the fact that they can pay for exactly what they use. So they don't have idle hardware sitting there just in case someone needs to use it. In the ideal serverless case, you're paying by the function invocations. They can scale to the sky. And what this can mean is that from a system that is absolutely idle, consuming no processing resources whatsoever, they can scale to running thousands of parallel function invocations per second if necessary. On the security side, instead of this monolith where it's very, very difficult to get an overall security picture of the application, every serverless function runs in its own virtual machine. Of course, on the serverless side, you'll find that there's broad commercial and community support in the way of training, education, developer tools, libraries, education, support resources, and the like. So that's my brief introduction to serverless, and let's turn things over to Ron to move forward from here.
Thanks, Jeff. I only think that my main concerns with the 2 pizzas team that I can eat 2 pizzas, so it just doesn't fit for me.
Well, as long as you can build and run your own microservices, I guess you'll be okay.
I'll try to. So thanks for handing over. I think we're going to dive now into observability, optimization, and security. And I just want to kick it off and talk about what's the traditional kind of way that we use to do monitoring and logging. Then maybe talk about the more broader term today that is widely used called observability, and especially how it impacts security as we move from the kind of old monolithic approach to the more microservices and serverless approach. And the first question that I love to start with is, why are we even monitoring? Many, engineers or ops people are usually the ones that doing the monitoring, and for them it's, just to make sure that the threshold doesn't hit something or the number of errors is not very, very spiking high. But ultimately, we're doing it for our business, for our product. In most of the cases, our product is our business. So making sure that our product and business are still vital and everything works accordingly, that's why we're monitoring. And when we start to monitor, we need to look for, what kind of signals are we looking to verify that the business and the product is working properly. And there's a good definition for the 4 golden signals, which are broken into main 4 ones. The first one is latency, and that's pretty straightforward. How long it takes for a request to be handled and get a response. So that's super important for your customer experience and your user journey inside a product. Then we're talking about the amount of traffic. Traffic helps us understand, are we handling the same amount of data or more? Do we have more users or less users? And then as a subset of it, how much of it is errors? We can take a look at it as a percentage or just the absolute number of errors that obviously when it indicates something bad when this number goes high. And the fourth golden signal that usually people are not looking at because they're not acquainted with that is saturation. Saturation tells us how full is our service. In other words, we can look at the past 3 months and everything will look right. Traffic grows steadily and latency looks right and errors doesn't grow at all. But then at some point our system will break because we reached the full saturation of our application and we just can't handle any more traffic, any more information, any more users, and all of a sudden, all of the rest of the 3 metrics will go down. And actually, I would love to ask you, Jack, what are you seeing today in terms of visibility into these kind of metrics and how it's interleaved with security?
Yeah, well, thanks. I was actually going to suggest that there was an interesting comment that Jeff made, right, about the spiky workloads and spiky data, right, and just the sheer amount and volume that we see in terms of the changing flow of information that we're monitoring as a result of trying to identify security concerns, because it's slightly different. It's like a series of ingredients, and you've got a recipe, and the recipe for understanding health involves these 4 golden signals, and each one of them, almost taken on its own, can give a great deal of insight right into one service characteristic that I care about. Security can be different, right? A single message about an error combined with a single change, an abnormal amount of traffic or saturation happening, or perhaps a system that's remarkably slow. I can put these things together in an analytic framework that can then tell me that there's a security problem that I want to look at underneath it. And I know we're going to talk about it a lot today, but one of the beauties of the granularity in a microservice infrastructure is that I get that autonomy, right? Those balkanized VMs for each one of these bits of functionality. But unfortunately for us as security people, right, we know that most of the security problem happens in a gap between things. It may have historically have been the gap between client and server, or between user interface and database. And those were the gaps that the folks could exploit. Well, now there's a lot more complex threat surface, a lot more gaps, because we're taking advantage of that capacity to make much more granular, much more individually defined bits of functionality that then have to communicate with one another. So the monitoring, particularly at that granular level, that amount of visualization of that data and that visibility is super important, because we don't always know when we design the system every way we're going to want to put it together, because threats change, attacks change, the configurations change. And so we want to have those individual elements available to us so we can construct the right analytics to arrive at the right answer about looking for bad things when they're happening.
Yeah, totally right. And then when we're doing this kind of monitoring, at least in the old school kind of things, or the agent-based kind of things, we had, like a service with a REST API, and it communicates to some database. And usually the way to collect this kind of vital signs or signals to look at our system, we would put an agent into the host or VM or any kind of other infrastructure. And this would start to collect the host data, like processes and network and disk and any kind of metrics that will help us understand the 4 golden signals. The main thing that, there are some limitations over that. And I think, monitoring perspectives, it gives us just metrics. Its inherent limitation is that if we're having some problems or we need to dig into more details, it's just metrics. It's just a data set of points in time and what happened at this specific point. It doesn't help us to drill into. And I think another point that's worth touching around security, Jack, is how agents are being changed over the course of time. That now that some of these services are not managed by you, or you don't have access to the host at all. How do you see that?
Right. Well, if you think about it, right, we're monitoring now more than metrics. We're more monitoring outcomes, right? Whether it's a transactional outcome, whether it's a completeness outcome, and dependent upon the individual behavior that we're trying to watch, we're trying to establish a baseline. right? A lot of security revolves around understanding when things skew from a baseline of expected behavior or skew towards something that we know is aggressive or malicious. And so the agents themselves have to have a lot more knowledge, a lot more wisdom about what they're gathering. And again, I'm going to jump right back to Jeff's statement about the spiky workloads, right? If you think about the way that complex analytics work, right? A malicious campaign or a piece of malware will sometimes be multiple components, right? And they're happening really, really rapidly. Well, if I see a spike and I've constructed sort of monolithic security, right? I'm not taking advantage of these same benefits, then I could easily be overwhelmed by the volume of data, which may render the analytics not even functional, or in a slightly better case, they may just be a lot slower, in which case I've missed my opportunity to create the security that I was looking to with the analytics in the first place. And it's something, you know, that Alert Logic, we spent a lot of time with scaling, in, especially inside that AWS environment, taking advantage of that granular control to be able to scale up the analytics with the same sort of violence that you see the applications themselves scaling up as they get through time. So I think it's a very, very different world in terms of monitoring. And I'll just give you one more point, if I could, Ron, which is that people's expectation of their security is no longer that they're going to arrive in the morning and get a report of everything bad that happened, right? One of the reasons that managed detection and response is thriving these days is because people want that interaction. They want that disruption of an attack or remediation to happen as fast as is humanly possible or machinely possible to eliminate the opportunity for having a larger blast radius and more damage occur. And so monitoring has changed. It is much more interactive. There's much more of a synthesis between my need for data and the results of the previous call for data. And so I think it really has changed to require the same sort of granularity of understanding and of interactivity as we see in the great way the new applications are being put together through the microservices and serverless.
Yeah. And then right after monitoring, you know, when we're having a problem, we need to start and, you know, roll our sleeves and start troubleshoot the problem. But with monitoring, we can't actually troubleshoot the problems. These are just symptoms or, you know, signals for something bad that might happen. We need some more debug data, or in other words, logs that helps us troubleshoot. And again, the same kind of attitude comes here as well, comes here as well, that you're having an agent-based like a software that is being deployed on the host. And, you know, in the very kind of traditional applications, it's even used to be dump it into a local file, then you could tail or look at. But in modern applications, we're tending to do it more into a centralized unit. So all agents report to a remote kind of log aggregator, and then we can easily see all logs. The thing that comes here with this logging kind of pattern is that we're only getting access to the logged data. It means that if in our code or our service doesn't log this information, we're just not going to see that, which has some, again, inherent limitation, or in other words, it implies that we need to take care for this kind of logging. And especially for logging, it's interesting to know what security perspective on logging, what do you correlate from them? What kind of insights do you get from, you know, ingesting logs from multiple services?
Yeah, it's funny, you know, if you think about it, like when networking was young and logging was the rage, everything went into logs, right?
Yeah.
And then as we became better at doing packet capture and understanding the traffic on the wire, people took a more real-time approach to watching what was going on the network, because before it ever got to a log, it was on the network. But because organizations have begun to deperimeterize so aggressively, what we're talking about today is another example of how we've deperimeterized networks and are really establishing connections from individual or role to data asset or to service. We find out that, hey, guess what? We're back to logs, right? Because so much of the traffic is encrypted and so much of it lacks the context of an actual operation, it's hard to use it for data. But you bring up a great point in terms of the granularity of the information that's available in most logs. You know, traditional logging was transaction focused. You successfully accomplished a certain task. If you didn't successfully accomplish it, well, that zero, that failure condition, or one actually, that failure condition just meant you've got a problem, right? It didn't give you much more data. I think one of the beauties of being able to log more granularly and gather that information, it provides us a rich source of correlated data. And when it's done correctly, it's already normalized, right? I already know where the fields are going to be. So if I want to construct a complex query to understand something on the fly and at scale, the information already exists in a form that I can quickly throw into the same learning mechanisms that I use to train my systems to recognize other kinds of maliciousness. So, logging has, come back into vogue again. It's a nature of the way these systems are working, but it's come back into vogue in a much more granular way, and I think a much more useful way for people who are trying to build these highly scalable transactive systems.
Yeah. Jeff, do you have any take on this? I see you nodding yes all the time.
So I was thinking about how much easier life was a couple decades ago when we had monolithic systems that ran on a server, and pretty much the level of control that we had of logging was, do we want like none or errors or infos? And it was pretty much a matter of, well, how much storage do we have and how much time do we dive through those logs? And now you think about a serverless application with maybe thousands of moving parts, each running at their own individual speeds. The fact that you don't really have they don't all get to log to a single directory because they're all running within their own execution environments. Time is effectively progressing at different rates, and so you need to kind of interleave everything after the fact to put it all together. And the ease with which we used to be able to simply turn on logging and rerun the reproducible test case, I suspect that those days are pretty much in the past, and that we need a much more interesting approach as we're talking about today.
And Ron, if I could follow up on Jeff's comment just for a minute, I think another really important piece of that, and I don't mean to wax nostalgic, but the idea that a host actually mattered, right? That server or that process name actually mattered is long gone. This is one of the places where we see security sometimes being the most challenging for people, in understanding that the touchstones of security for them for the past 15 to 20 years are gone. Host, user ID, process name, it's all gone. Right? Because everything is so evanescent. It comes, it goes, it's reconstituted. It's not a user, it's a role. The user can have a number of roles. A role can have any number of users, and they're permitted to services or assets or some combination. And so it's changed almost completely, right? The language of security has changed because the foundation upon which we build it has changed. And I think it's better, it's more complicated, but allows us to make a lot more nuanced judgment about security in terms of how we either enable it or how we detect somebody who's trying to get around it. So I think it's all good, but man, it is nice to look back and say, I remember when.
Yeah, also running at scale, I think as we talked about the golden signals, and some of these issues aren't, did it work or not? The kind of a nice just binary result. It's how often does it fail, and are we seeing trends, and do we see that error rates are going up, or do we see that some service that should have been a somewhat quiet service is suddenly really busy, and you're like, huh, that's kind of interesting, and oh, that might mean that someone is trying really hard to unlock a door and trying a bunch of keys to get in that door. So we have to look at this, not individual items still matter, but trends and patterns and statistics matter as well here.
For sure.
Yeah. So that leads me, to the last part of the slides, moving fast forward into the future of engineering and the way we build our products. So we have two kind of attributes that we can talk about when we're building an application. The first one is where the application is hosted, and the second one is the pattern that we're using to design our application engineering-wise. So we started with the traditional apps that we just talked about, host-based, monolithic. We took care about network and disk and power and things like that. The application was super simple back then. And then the course of time, we start to break down our applications into pieces, which really help scale only what matters and look at build the services in a way that is loosely coupled. So each team and each part of it could be built in a parallel, and they were communicating to one another. And then at the last step, we took it into even a more amplified kind of era, where the application becomes super distributed, and the host in most cases are inaccessible, or there is no even host that we can interact with. For example, if we're looking at this example, an application composed with container services like, ECS or Fargate, and then some Lambda functions and third-party APIs that you don't have any host at all. It's just an API, and message queues and web servers and managed databases. All these take our application into a different kind of level, different kind of complexity. And, for you, Jack, actually, the last question, what's this kind of application structure changes the way security is observing that?
Sure, and I think the easiest way to think about it is it makes security a much more composite function than it used to be, right? In terms of its enablement, the way that I think about feeling good about my security as I'm programming, and I'm sure we'll talk about this a little bit later on, but some of it's in the construction phase, right? You mentioned, doing good logging, making sure you're gathering all the information you need. But there's also other things, right? If I'm using API gateway and I want to make sure that I'm not having somebody misusing something, I may want to implement some of my security controls, my authorization controls inside the functions themselves, right? Almost like a double check. And when I want to be looking for the security of the service, right, as a whole, which either is a small thing or a large thing, I think ordinarily what you want to be watching for is the expected outcomes from that service and from the steps along the way, right? So I can take an individual, if I've done my logging correctly and have enough visibility, I can take individual components from 3 or 4 of these different elements and weave them together to understand when I'm seeing something that either I don't expect, or through our threat researchers, I recognize as a pattern that's associated with some known malicious behavior, whether it's like locally a privilege escalation of some kind inside, or somebody taking advantage of a misconfiguration inside the formation of the service itself. So for me, it's created a real, it's a data challenge, right? It's almost puzzle solving, understanding how I can get enough information in a way that doesn't impact negatively the performance of the system I'm trying to monitor, and then put it all together inside an analytic infrastructure that allows me to drive conclusions and do my managed detection and response really quickly to make sure that it stays up and safe. So it's just a different kind of puzzle, different amount of blocks.
Yeah. I think I'll hand it over to you, Matt, now for good stuff.
That sounds good. So, thanks a lot. And I guess one of the things I want to level set with everybody is, again, the thought process is, as we're observing customers moving into more microservices architectures, they're doing this to support their business. There's business agility. There's a need to be able to do things faster. Serverless is a great way to do that. And part of the reason for having Epsagon and Alert Logic in the call today really was to show that you do have to focus on different things in a serverless environment when you're doing things to support your business agility, but that there are solutions and there are options to be able to manage security more effectively, to manage observability of this modern architecture more effectively. And I think I've got actually a question here. Maybe we'll ask the folks over Ron here. I mean, your experience, what are people looking for? Maybe it's a checklist or something like that in a monitoring or observability solution in these more modern architectures. What are you seeing?
So first thing that I see, it's starting to change from the traditional IT departments more to the engineering departments. And for them, they already got their ecosystem. And, this is actually a good example of an ecosystem that is application-wise and also, interface-wise. Like, what's the solution today that you're using to get on call or incident management? And what are you using to work and collaborate with the team, and where your logging solution is placed, and what cloud vendor are you using? So first thing that people are considering is what fits my my application and my teams in the simplest nature. Second thing is about I would say adoption at the teams. So usually engineers are turning to be like, they're getting picky about what kind of IDE are they using and what kind of open source are they using. So for them, it's really hard to get them acquainted with the system. And actually a good kind of tip for everyone, start this kind of a process of obtaining a new tool in your organization from bottom up. Don't try to enforce people to work with a tool because this is my ID and this is my tools and this is my, start from, from one person to one team, then several teams. That way you can adopt it at most. And then the last one is, the main consideration every organization is having is either you're doing it do-it-yourself style or picking up a managed solution. And here, there are trade-offs for here and for there. I just, recommend everyone to evaluate several tools and understand the trade-off between each and every one of them, because going on a do-it-yourself kind of tool will require a lot of engineering resources that you don't want to spend, especially when you're doing serverless and you want to focus on what matters. On the other end, obviously, managed solution has its price, but again, you need to compare the total cost of the price and not just a single item. And actually, with that, I would love to take one question for Jeff. Serverless, so everybody talks about it that it's either cheaper or much more expensive. And I'm curious, what do you see, from your data, and what do you see from the people that you're speaking with? In what scenarios serverless might be more beneficial in terms of the total cost, and what cases it doesn't fit?
Okay, so we've actually done quite a bit of analysis and spoken with a lot of customers to try to understand this. And when we look at the overall cost of their compute resources, we see that using server-based processing and serverless probably about the same. The benefits that our customers are sharing with us, they say that time to market is greatly improved. They can go from, we've got a great idea, to we focused on implementation versus infrastructure. We got to the point of having something deployed and in production very, very quickly. So they're starting with code. They're more, they find that scalability is not something that they worry about, but they say we effectively, by using serverless, the scalability is really in there from the start. So they're feeling very confident about that. And they're finding that overall long-term, as they go to serverless, that because they can maintain at the microservice level, they can test by simply putting parallel versions of new versions of microservices into play, and sometimes even running the same events and logic through current and future implementations. Customers are saying that long-term maintenance, they think that this is going to be more affordable in a serverless environment.
Yeah.
Let me ask a question here to Jack. How do you think the overall adoption of microservices changes the customer's role in the shared responsibility model?
Yeah, that's a really interesting question. I'm going to refer back again to another point that Jeff had made, which talked about the unintentional organizational changes which follow architectural changes as they move to microservices. So if we think of shared responsibility in the model, right, there is, from the concrete up to the hypervisor, you've got this really trusted organization that's got it all going on. Then I get inside the container and it's kind of my responsibility, right? But the problem with that statement in a microservices implementation is that I pretend that that's static, right? That the way that I built my thing inside the container is going to continue to be used the same way, just like it was a monolithic app, and that there'll be some huge change control process before anybody makes a switch. Well, that organizational change piece has a huge amount to play here. A lot of what happens in security historically has been institutional knowledge. We know you don't use the function that way, right? We know that you don't do the following sets of things, and we know we use this protocol, this length of key to do this style of encryption. But in this environment where I'm leveraging that incredible capacity to reuse componentry, I can't have that control anymore, right? So if I were to look at sort of the #1 change in the shared responsibility model as organizations adopt microservices and serverless, it's you have to have a much better sense for your governance, right? You've got to, and I hate to sound like a policy guy because I'm not, but you have to have a much better set of controls so that you understand the way that people may decide to plug these pieces together in a different way that you're not necessarily expecting when you built it in the first place. And if I could tap one other thing, and it follows up on Ron's question, which is, what are the benefits as people are going to it around cost? That whole time to market question is a really important one, right? The idea that I can get to market faster is absolutely right, but right? And I hate like security is like the downer profession sometimes, right? But there is this security concern that you have to be thinking about. Look at me, I'm going to get in the market because I can use these 11 different components that I'm pulling from different places. And look at these functions that are so neatly reusable. Hold on a minute, right? Those are being used to generate invoices off of open source sales data. And you're now using them to be able to pull employee data associated with healthcare benefits. Hold on, right? And so there's this idea that to be good at this, your observability of the functionality and the way you think about it documenting itself and presenting itself so you can understand better the risk as you're putting these things together. I think that's another change, Matt, in the way that the sales, in which the shared responsibility model changes, because it's no longer I'm responsible for this blob, right, that it lives inside some bucket. I'm now responsible for all the features and the functionalities and the trust that people have given me around the elements of the data as they live in that containerized world.
Yeah, that makes
so
a lot
Jeff,
of sense.
when you describe that, it maybe kind of think of these older monolithic apps, some of which I might or might not have had a part in, where you think about that things at the outer levels closer to the APIs or closer to the customers. That was formerly the trust boundary to say, well,
Right on.
let's make sure things don't leak in from the top or from the outside. But then as you get deeper and deeper into that implementation, say, well, I am the caller myself. I wrote the code, or it's my colleague across the hall, and I trust them. So you suddenly get a little bit lax in these monolithic applications about the security at the deeper levels. I do think when we think about serverless and the fact that we've got all these functions that are really, they're all effectively open for anyone within the organization to call, that you don't really get to make that mental shortcut of saying, oh, I implicitly trust the caller because I am the caller myself. You say, well, I need to be a little bit more general. I need to effectively distrust my own colleagues and put nice security boundaries around each one of my microservices versus saying, I will trust the outside to protect anything bad from getting in.
You know, that is a really exciting analog, Jeff, that I've never used, but I will steal now, because it's the same way that security used to be focused on the network, right? That I could balkanize myself with some firewall and some external versus internal. It never really worked, right? We always referred to it as the hard, crunchy outside, soft, chewy center model for security, right? But it's the same thing, right? The monolithic application, I pretended that by authenticating someone into the application, that everything they were going to do inside was going to be okay. Right, and now all of that feature functionality that's capable of being used, individually and atomically inside has to be protected in the same way. And it's much like every user who now travels and is working from home off their laptop is suddenly outside the bounds of what I thought was that safe encasing shell, and they're out on the outside. So it's almost as though serverless and microservices have brought us into the application componentry working from home, right? And we have to start thinking about it in the same way.
Yeah. That word you used, deperimeterizing, which was a new one to me today, but I think that applies here.
That's good. I think I still owe you one.
I love that. Ron, you mentioned something earlier about in-house solutions and maybe when it's appropriate because you want to be giving sort of the authority for folks at the ground level to be able to tool themselves. Is there a time when a company should be considering some sort of an in-house solution to help them with this?
Yeah, so I think there are two checkpoints when you're considering the solution and you're considering whether to do it yourself in-house or have a managed solution. One of them is at the beginning, when you know that you need observability and you want to accomplish tracing and metrics and logs and everything to get your up the ground. So this is the first time to consider that. Now, if you're relatively a small company, I would definitely pick go with the managed solution almost at any cost, because otherwise, let's say you're a 100-people company and you have tens of engineers, it's probably going to mean that you will need to dedicate, a team or at least few engineers, maybe 2 or 3 that can eat a pizza to build the observability for your organization. Now, I'm not sure that that's the best time, in a company lifespan to spend so much engineering hours just to gain monitoring. So this is the first fork where you can try to decide here or there. The second part is that you're having a scale, I would say billions or tens of billions or hundreds of billions of requests, something that the pricing starting to be a matter of fact. And organization-wise, you need something that is really tailored for your needs. And that's the other part of the spectrum, companies of, hundreds or thousands of engineers that, super modern applications, and they need something tailored and they need to enforce it across all teams and allow all teams to, to contribute to that and develop that. So this is another fork in the process to think about it. And again, this is really, I would say, applies for really big kind of enterprises or really big companies that can devote themselves. At this point, by the way, the total cost operation, like developing and maintaining and running this, would be a huge project, but it might be considerable, because otherwise it's, pricing wise for this kind of scales starting to be a matter. But again, at the first step, try to pick a managed solution and go out only if it doesn't fit your culture, doesn't fit your needs engineering wise, or doesn't fit your budget at all.
So looking at the diagram that we have on the screen right now, I think really resonates exactly with what you just said, Ran. I look at the services that we've got as part of this, just even the simple functional ones like the SQSQ. This was one of the first AWS services we launched. I think it was launched in 2004.
Yeah.
Incredibly robust service, but we still continue to make it more efficient, increasing availability, increasing scalability. And the individual organization could certainly start to build one of these themselves. They'd have to relearn the lessons that we have well over a decade of many engineers contributing, making this better, from more different customer use cases than an individual customer would ever see. So when you look at the breadth and diversity of cloud customers, and they're all making use of this same service, they're going to push it in so many different dimensions that by the time the next customer steps up, the odds are that service has already been battle tested for year over year in that particular situation that the next customer is going to present to us. So that's not to be underestimated as the value that you get from packaged services and cloud services.
Yeah, I totally agree. And again, even in such scenarios, you're seeing sometimes people building their own message queuing system, based on open source, but still building all the outer kind of layer. And again, this really depends if SQS fits your needs, and probably in 90-something% of the cases, either SQS, SNS, or Kinesis or something similar would do the job. Go do that. I mean, why build a message queue? It's so painful. I'm pretty sure that dozens of engineers wasted
to build SQS so great.
Right, and as engineers, we like to build things. This is the really interesting challenge, and we have to make a bit of a change here and say, yes, we would love to build the next SQS or the next S3 or the next Kinesis data fire hose, and we certainly feel capable of doing it, but the organization would love us to actually focus on the code inside all of these Lambda functions. That's where we can add our unique value.
Yeah. And if I could, one of the benefits to the customer is the long-lived nature of this ecosystem, right? As a guy who built my entire third company based in AWS, right? I can tell you that there's a richness, both in terms of the capabilities and the support and understanding for what goes on. So there's all of that. And your point about all the different ways in which it's already been used and exercised is such a great one for security, right? There are a few corner cases that haven't been tested for SQS, as an example. So I'm not super worried that there's going to be some underlying security components. So as I'm trying to figure out how I rate my risk, the use of elements from this well-tested, well-used ecosystem, they decrease my risk over time. And it really resonates with the way we think about security, right? So at Alert Logic, we've got thousands of customers, and so we're watching all of their behaviors. And so we see the way that people interact with it. And so we may see something that goes wrong in a new way at some customer over here because some new attack type, and suddenly everybody knows about it. And I think functionally and stability and for purposes of reliability, elements like this in the ecosystem benefit from the same scale, right? That so many different kinds of people, so many different kinds of organizations are using it in so many different kinds of ways. It makes it not only a robust technical component in terms of its functionality, but as a security person, it gives you a lot of comfort that the thing's already been really well vetted out.
There's a very interesting logic that says when you are running at world scale and all of your APIs are published and public and the whole world is trying to figure out ways to circumvent what you've done, the scale is actually a benefit in the sense that because you're inviting everybody to try to peek and poke and see what's going on there, all of the unique situations arise at scale, and you deal with them once, you deploy the code out to wherever you need to, and you've addressed it globally very quickly.
Sunlight
By
is
the
a
way,
great disinfectant.
yeah. By the way, a quick history lesson. SQS is indeed the first service in 2004, something like that. Then came EC2 and then S3. Many people pretty sure that EC2 or S3 are the first services, but actually it was SQS.
It's one of the best trivia questions. Is which one of the service?
It's still very, very heavily used. So I'll encourage anybody who's on here, if you want to ask questions, by the way, get your questions into the chat. We'll start getting those out there right now. I just wanted to let folks know that if you can put your questions in there, we'll answer them as well. Sorry, go ahead.
No, I was just going to note that when I wrote the blog post that was announcing SQS way back then, and we certainly had lots and lots of plans, and I knew that S3 and EC2 and other things were in the development pipeline and things were getting built. But we didn't want to make a gigantic splash. We simply thought, let's just put this out here and the right people will find it and figure out what's going on. And sure enough, we put SQS out there, and the people that understood that that was a fundamental component of a scalable distributed system, exactly like what we have on the screen, they looked and said, that's kind of interesting. Something is up at Amazon. I don't quite know what it is, but something's up. Most of the world looked at it and said, why is my online bookstore selling me message queues? This is a little bit odd. I remember those early days very fondly with just putting those first couple services out there. And SQS went out there, little bit of like, that's unique and interesting, but a little weird. And then S3 is like, storage, that's pretty cool. And then processing. Oh yeah, now I'm starting to get the picture. So you're bringing back some great memories of the early days of AWS for me.
I love that. I love that all this stuff is obviously still very important to the business and important to customers today. No question, it has value. Let me ask a few questions here. So I guess, Jack, we had a question from one of the attendees here. How are you extracting the Postgres auditing log related to sort of the security perimeter and anything to do with security and infiltration?
Sure. Well,
or is that something doable?
Sure. There's this, if you think about it, there's a series of different ways in which we can ingest information through the pipeline, right? Depending upon the scale at which we expect to see it, and whether the state of the data as it's being transmitted, we pull it in different ways. The system, interestingly enough, at Alert Logic, is set up so that we're extracting all the information, but only extracting from it those individual elements that are necessary for us to feed the individual vulnerable conditions that we're looking for, or the individual malicious attacks that we're looking for. So all of that's being pulled into our own proprietary information pool, and then being stored and normalized so that we can then process it into the analytics. So there's a variety of different ways we pull data from the different kinds of data sources. And if anybody's interested, I'd be most happy to get back to them with a more technical, architectural answer for it.
Okay, excellent. Let's take another one here. It's probably for Jeff, I think, here. What types of customers are you seeing leveraging serverless today? I mean, is it just like a startup thing? Is it a Greenfield Development story?
It's really all types. And I think back to when we launched Lambda, and my first thought was that Lambda was going to be a great benefit to startups, because they were starting from scratch and they could build their entire architecture in a serverless model. But I saw the enterprise and the corporate adoption happen very quickly. Large enterprises of all sorts have jumped in, and like we talked about earlier, the time to market is just a huge competitive edge. And in parallel with that, and I often speak to customers about this when they come to visit me in Seattle, this kind of parallel between the microservices architecture and the team structure, the org structure. And they're saying, okay, they've known for a while that their monolithic apps and their monolithic teams are just not going to let them go into the future. And they say, well, we need to break up the app and we need to break up the teams to go along with it. So it's very interesting that the tech change actually drives the cultural change and the organizational change.
If I could add, I think one of the interesting things that we've seen amongst the customer base is that there are certain types of applications, either because of the way in which they work or because of the groups or the business units they're supporting, they're just more natural, right? They more organically move towards serverless and to microservices, and there are others which remain, that are going to remain forever in those back-end much larger systems. And so then you find out there are projects to use serverless to make them more accessible, right, or to leverage the data in a new way. And so I think it's really natural. I think that while there is greenfield work to be done, which is great, I think there's an enormous amount of cost savings and benefit to simplifying the interactivity with data that may exist in some legacy data store and bringing it into this generation through serverless. I think there's a huge amount of value there. And one of the things that we see at Alert Logic is the capacity to watch the security problems in the old world and understanding the challenges of security in the new world. Most customers we talk to are interested in the synthesis of those two things. Very few are purist. Most of them exist somewhere in that hybrid range.
Yeah, so Jack, to build on what you just shared there, a lot of customers are telling me that they like to think of this as they're ripping the monolith apart, they're unlocking all this business logic that up until they did that business logic was super important, but it was totally encapsulated inside that one app. And many companies, believe it or not, don't actually have great ways to share code across teams and across applications. They end up copying and pasting or re-implementing that business logic multiple times. And as they start saying, let's actually put this into microservices, they can have this opportunity to now centralize the business logic. They're reducing duplication, but they're also saying, here's something that's central to our business. We effectively invite others within the organization to reuse that logic that we've invested in for so long, and they're unlocking that logic that was just formerly trapped inside of the monolith, and they're seeing some great benefits from doing that.
Yeah, we're doing the same over at Epsagon, by the way, where once there is a common service or a common tool that everybody uses, we just release it internally as an open source. Then everybody can take it, look at it, use it, and even contribute to that. I think that the powerful part comes when people are starting to contribute to this kind of internal tools, and then it's getting much more enriched over time.
Absolutely, and I think that power is partly about the fact that they had the opportunity to contribute, but each time you make that little contribution, you feel a bit of pride of ownership, and you say, this isn't just somebody else's tool, this has got a little bit of my own creativity embedded in there as well. And I see the same thing with the microservices move, where if you're just one developer on a team that's putting together a monolith, you specialize, but still the ultimate thing is just a product of the team rather than of a person. When you are part of a small team, and when you know that your team owns a very specific function in there, that sense of ownership and the sense of being proud of what you do and wanting to always do a great job, that's been shown to increase as well.
Yeah. All right, so I guess one more question here, and it's just sort of my question, so fully admitting that here, I guess. But for Ron, observability is one part of the overall sort of issue, I guess, when you're building a modern application. Anybody can look at logs and monitor things, but I think when I look at Epsagon's solution, what you guys have done that's very unique is you go beyond just monitoring stuff. Can you talk about some of the things you're doing to help just make remediation and troubleshooting a whole lot easier, leveraging that solution?
Yeah, that's actually a great question. The main thing that we built, like our unique proposition is first to have all of the observability parts under the same tool in a seamless way. I mean, you usually find yourself organizations having one or even more solutions for logging and one or more solutions for monitoring metrics, classical APMs, and then another solution for tracing. And this is just turns to be very inefficient, because you find about the problem on your APM, then you troubleshoot your problem in the logs, and then you need to understand really the correlation of each and every service as part of the request, or you go to the tracing solution, and this just doesn't scale well. This, it's getting to be more and more complex. So first thing that we pulled out is to have all of them together, but real together. For example, you're looking at, the spiky or database, so you're interested to see all of the calls to that database that were spiky and that, a certain time frame from the specific services that we're communicating in this spikiness traffic, because database can have 10 services that are communicating to. Then you're seeing the trace, you're interested in more logs, you can see them. And then the last part that we pulled into Epsagon is to try and take the word of trace into something more meaningful, because a trace, honestly, all it does, you can switch it with, like this is first, and then this is second, and this is third, and this is how they're connected. But we took it to the further level. We said, this is service one. service 1 sent this actual payload to service 2, and service 2 sent this actual payload to service 3, then you can exactly see what is the intercommunication between each and every service. So it's much like, you know, a structured logs, but that contains every deal of your application, which allows you also to search for it. Now, you know, comes a user that will say, hey, Matt, I browsed to your website, but it didn't load correctly or something bad happened. Easy, you go to Epsagon, you click like user ID equals, you know, that user or that user email, and you can see it through the payload comes and exactly what happens. So we really pull these two, you know, triggers to help really engineers adopt a complete solution that brings them both the monitoring, the classical kind of monitoring, but a much more enhanced experience for troubleshooting.
Definitely. And it's the speed of being able to resolve these things quickly that really helps organizations get stuff out much more quickly. You're leveraging serverless architectures to do the actual infrastructure and the compute. You're leveraging things like Epsagon to help with the monitoring, the debugging, and of course, Alert Logic to help with your security perimeter. Exactly. Actually, a quick note over here. You know, when we started, we spoke about being an APM for production. You know, production is the most important part of your system. But we found out that most of our users not using it just for production, but most of them are also using it for development, because Epsagon turned to be their one place to go when there is a problem, regardless if it's production. Because, you know, most of the problems that happens, you know, in a good healthy system are in the dev or staging stage. So you find out about, like, you know, the problem in dev, you go to Epsagon to look at the logs and the traces, you fix it, and then you iterate, you know, back and forth. So we found out that most of our users are using Epsagon, you know, also in dev, and that was super enlightening, because then it hits us that engineers are looking for easier way to troubleshoot. I'm pretty sure that it's similar for security, but engineers are looking for easier way to troubleshoot because it's just getting complex, you know, getting super complex over these kind of applications.
It actually makes a lot of sense to me, Ron, because I think that in any kind of system where you've got metrics and dashboards, you need to look at all of those things under normal operating conditions and develop almost an intuitive sense of what does normal look like? What are the patterns? How hot, how busy? You're looking at the signals you talked about. If you only pay attention to those when they're firing alerts and they're out of bounds, you haven't educated yourself or trained yourself to what normal looks like, and you're not going to necessarily see what you can look at the numbers and say, well, they're heading toward bad spots. You'll only have that background if you trained yourself by looking at the numbers during dev and test. So it makes a lot of sense to me.
All right, so we don't have any other questions here, so I think it's a good time maybe to move on to the sort of the follow-ups here. We do have, I mean, you'll get access to the slides here. We'll make sure you can review these links more in real time. It's hard to click through stuff, obviously, in a webinar session here. But we do have education, we have workshops and best practices if there's interest in doing more with things like serverless today. We have a serverless immersion day, including something that can be done remotely. There's a number of different free training courses online. We recently launched a well-architected tool online. So you can actually look at some of the best practices and have your architecture reviewed with this technology to help give you some of the best things you can do to make your serverless environment work as best as possible. But also wanted to call out some of the other information here, free trials from Epsagon and from Alert Logic's ebook. Great references to take a look at as well. I don't know if there's anything else we wanted to close with from any of the other folks.
Just a quick tip for this kind of situation that we got into. I really want to put people in a place that they try to manage or balance their work-life ratio. I'm seeing people, drowning in tons of work, starting from 8 or 7, or even in Jeff's scenario, taking the dog out for a walk at 5 in the morning, all the way to midnight. Try to find yourself a good balance with your wife, girlfriend, kids, and family to have it, because it's super important. Otherwise, you'll get too much friction and it kind of loses you. We don't know exactly how much time we're going to stay for in this way, so make sure you're having a good balance.
Totally agree. And it's actually important just to declare an end to your working day. Turn off the lights, close your laptop, step out of the room, change into non-work clothes if you have to, but giving yourself a little signal that says, I'm done for the day, I find is actually pretty important.
Yeah, absolutely. Well, excellent. Thank you, everybody, for your commentary. Thank you, everybody, for watching. And please, if you have any other questions, please don't hesitate to reach out for us, and we're happy to help answer some of these things. So, again, with that, thank you, everybody, for the time.
Thank you all.
Thanks, everyone.
Bye-bye.